Hi, this is Sir Darren, your online teacher. Today, we are going to talk about direct variation. Let's start first with its meaning. Direct variation is a type of proportionality wherein one quantity directly varies with respect to a change in another quantity. This implies that if there is an increase in one quantity, then the other quantity will experience a proportionate increase. Similarly, if one quantity decreases, then the other quantity also decreases. In simple illustration, as you can see on the table, as the value of x increases, the value of y is also increases. And as the value of x decreases, the value of y also decreases. So what does it mean? Both the value of x and y are going on the same direction. If they are going up, both of them are going up. And if they are going down, both of them are going down. That's what it means for a direct variation. A direct variation is a general formula of y is equal to k times x. Okay? So the value of y only depends on the product of k and x. Okay? So a direct variation, again, once again, that is just a comparison of two quantities. Okay, two quantities. So we got the y and the x here. Now, what is k stands for? K stands for the constant. Later we are going to get the value of that constant. I gotta teach you how to do that when we are dealing with this with the word problem. Let us take this problem and solve for the value of y. If y varies directly as x and y is equal to 15 when x is 9, find y when x is equal to 3. Alright, so we knew that the general formula for any direct variation is equal to y is equal to k times x. Okay, the product of k and x is equal to the value of y. Alright, so the first thing that we are going to examine here is to observe this first phrase. It says here that y varies directly as x. So y comes first, that's why you are going to put it there. And x comes second, that's why you are going to put it there. Okay, you getting me? So for instance, if the statement says x, okay, if x varies directly as y, it will become like this. X varies directly as y. Okay, so the position of this variable depends on the order on that specific phrase. You getting me? So you should observe the construction of that phrase. All right? Okay. Now, so we're going to get the formula of this. So y varies directly. So the equation for this is y is equal to kx. Okay? So it says here that y is 15. So y is 15 when x is 9. Okay? So the value of k is the missing number here. Okay? We are going to get the value of that k. Okay? So how are we going to get that? We are going to divide both sides by 9. Okay? So 9 will be cancelled and leaving that is k. So 15 over 9, you cannot divide 15 over 9, but you can simplify them. So 15 and 9, they have a GCF of 3. So 15 divided by 3 will give you 5, and 9 divided by 3 will give you 3. Okay, so the value of our k is 5/3. You're getting me? It says here, find y when x is 3. So given the same equation, y is equal to kx, our k now has a value of 5/3 and our x is 3. The question is, what is the value of that y? Okay, now 5/3 times 3, you're just going to cancel this one. Or if you want, you can multiply 5 times 3, that is 15 divided by 3. still the answer is 5. Okay? So the value of y is 5 when the value of x is 3. When the value of x is 9, the value of y is 15. You getting me? So what is the value of the constant of proportionality? It's 5/3. Let's have another example. If z varies directly as m and z is equal to 3 when m is 5, find z when m is 15. Okay? Now, again, as I told you a while ago, we have a general formula of y is equal to kx. But you cannot find the variable of y. You cannot find the variable of x here because the given variable that we have here is x and m. So what are you going to do? You are going to observe that race. It says here if z varies directly as m. So what comes first? It's z. So it means this y will become z. K is still there. And that x will become m because that comes second. All right, so our equation here will be z is equal to km. Z is equal to km. Now, let's have the first situation. It says here z is equal to 3. So z is equal to 3 when m is 5. When m is 5. So we are going to solve for this k. All right, so how are you going to solve for that? Okay, you are going to get take out the constant, the coefficient of this side. The coefficient of this side is 5. So you are going to divide both sides by 5. Okay. So leaving okay, k is equal to 3p. It means that our constant of proportionality is 3p. All right. Now, using again the same equation, z is equal to km, we have now the value of k, which is 3p. Okay. But we are going to use the second situation. It says here that find z when m is 15. All right. We already solved the value of k, which is 3/5. We have the value of m, which is 15. We are going to find now the value of z. Okay, so 3 times 15, that will give you 45 over 5. Okay, and that will become 9. All right. So, or if you want to, you can cancel this one. So leaving this 3. So 3 times 3, that will give you still 9. All right. So when when m is 5, our value of z is 3. But when the value of m increases to 15, the value of z also increases to 9. All right. So let's have another example. Try to pause the video and solve for the value of r. All right. So let's solve this problem. If r varies directly as z and r is equal to 6 when z is 5, find r when z is 10. Okay, so we are looking for the value of r. All right. So again, we have uh, we have a general formula of y is equal to kx. Okay, so you cannot find the variable y there. Okay, you cannot find the variable x. All right. So what we can see here is this variable r and z. So what comes first, r or z in the statement? Very good, r. So r, you are going to replace y by r. So k and our x, we are going to replace that by z. So our equation is r is equal to kz. R is equal to kz. All right. And then we are going to use this equation on the first situation. That is the first situation. This is the first situation where the value of r and z are given. Okay? So the value of r here is 6. The value of k is we don't know. We're going to solve for that. And the value of z is 5. Okay? So we are going to get the value of that k. So we are going to divide both sides by 5. to take out this 5. Okay, so that we have only k here on this side, and 6 over 5 is already in the lowest term. Okay, so the value of k is 6 over 5. And then, using the same equation, r is equal to kz, okay, we are going to go to the next scenario or the next situation. It says here, find r when z is 10. Okay, so we're going to find the r. We already found the value of k. What is the value of k? 6 over 5. Okay? And what is the value of z? The value of z is 10. You get me? Alright. Okay. Then you are just going to multiply this, okay, using the cancellation. Okay, so 5, and this will become 2. So 6 times 2 will give you 12. So the value of r is 12 when z is 10. Alright? There you go. Okay, thank you for watching, and I hope you learned something from our discussion today. So if you have some if you have some topic that you want me to discuss too, just comment down below, and I'll be glad to make a video out of that. So this is your Sir Darwin signing off. Bye bye.